Hey everyone, this is Matt with Fast Fuel Injection, and we're going to be doing some videos, show you how to get the most out of your XFI, make some changes when we do updates, things like that. Today, the first video we're going to go over is when you've been running the 2.010 software and you're going to upgrade to our newest 2.051. So now I'm going to take into account that we've already flashed the XFI. In fact, I'm going to go over flashing in a separate video. But to verify that, first go online, and then we're going to go to View and go down to Display ECU Configuration. And right here you'll see where the ECU firmware, this one's XFI2 underscore B9. B9 is the latest firmware, and that's the one you want to be running. And then this screen also shows a few things like your serial number and what options you have. Like this one has internal data logging, and of course it is a 2.0 box. Alright, so over here we made this document to kind of highlight what we're going to do. This is available if you email us or something. We can send this to you to kind of help you through as well. But first up, we're going to go up to View, and then Spark Functions, and then Spark Offset versus FEC. Now, FEC means Fuel Energy Constant. And what that is when you have like a flex fuel sensor hooked up for E85 or some other alternate fuels, it'll actually vary the spark timing for you as the fuel composition changes. So this table, it didn't exist before in the 2.010 software. So what we've got to do is take and zero it out, because it actually shows negative 32 right now, and so that would basically take away 32 degrees of timing from your spark table. So all we have to do is just highlight the whole graph and then hit the number 0 and enter, and we're done on that one. Next up, number 2 here, we're going to go up to View and then Individual Cylinder Corrections, and then the individual cylinder fuel table. Now once again, this is a new one that didn't exist in the old tune-up, so it just basically has a bunch of gibberish numbers in here. So start at the top left and drag all the way down and highlight the whole thing, and then just hit the number 0 and enter. Next up, number 3, we'll go up to View and then down to System Configuration and Operational Parameters. Now in here we've got a few new things. First up is going to be here, this minimum oil pressure cutoff. If you're running an oil pressure sensor, and of course the pressure gets too low, you can set a pressure for it to actually shut the engine down to help protect the engine. Now in this application we're not running one, so we want to uncheck this, and at that point this number here in the box doesn't make any difference. Next up here you'll see there's now a spark cut rev limit. In the past, we had always used the fuel limit, which is what you see here, fuel cut off RPM and fuel cut on RPM. And the spark cut, a lot of customers requested a spark limiter instead of the fuel. Typically, I would set the spark cut rev limit at the same as the fuel cut off, so 6,500. If you notice, it was showing 50 in the tune to start with. Once again, that parameter was not there in the old tune, so it just kind of put a bogus number in there. So it will not start if you don't fix that one. And then also down here you'll see remote baro sensor enable, and this with the 205.1 we added the ability to add a separate strictly barometric pressure sensor, and what that does is it live corrects as altitude changes. So if you're climbing a hill, as the barometric pressure goes down, the computer automatically compensates for that. Pretty neat feature, but we're not running one on this one, so we want to be sure and uncheck that. And then hit apply and OK. Now next up we're going to go with step number 4 here. So we'll go up to View and down to System Configuration and then Ignition Parameters. And this is a kind of a new window for us. It actually used to be all kind of in the operational parameters. It's separated out a bit now. So you'll see your crank reference angle. 50 is correct for this one. Now we're actually using an XIM on this particular application, so we want to choose IPU/XIM. Also IPU would be if you're running a 2-wire crank trigger, or MSD distributor or a fast dual sync distributor, you're going to use the IPU/XIM ignition. And just hit apply and OK. Now next up we're going to go to step 5, and this is something totally new in 2051. So we'll go view, system configuration, and then XIM/EZLS parameters. And we want to check the base dwell table. Now this one here, as we can see, it starts out at 0, and this is just no good. So what it is, new table, it was unpopulated from the old tune, so we need to fix this one. Easiest, quickest way to do that is to go up to File, and then Paste from File. And we want to make sure that we're in the ICT folder. So the way that would look, like if you're coming in from C drive, if you're trying to find it, and go to the CCOM WP XFI 2051 folder, and then there you'll see the ICT. And this is also where we keep like the injector offsets, the different map sensor calibrations, things like that. If you scroll down, you'll see the XIM EZLS dwell. Just open that guy, and then that's going to paste over that dwell table for us to the basic parameters, just like the normal XIM dwell settings. Now also there's a couple things with dwell control. First up, if you see here, there's the dwell override table, and right now that's checked, so that means we're actually going to be running over the off of the dwell table. If you don't want to do that, just want to run it like we have in the past with the XIM, the default settings, all you have to do is just simply uncheck that and then apply OK. Now also an important table to check, especially if you're using the dwell table, is this dwell modifier table. What the dwell modifier table does is based on TPS down here. So at low throttle or idle, when we don't really need a lot of energy out of the coils, it basically decreases the amount of dwell. It keeps from getting the coils too hot, especially on things like modular Fords, something like that. So what we want to do is put a decent kind of a baseline in here, and a good place to start with this one is typically at idle or 0 TPS throttle, about 40%. And then of course when we're wide open, we want to have full power out of the coils, so we'll go 100% over here. And then we can just highlight the whole graph and interpolate in between. This kind of gives us a linear graph. As you get into the throttle harder, it gives more juice from the coils. And this is something you may want to experiment with a little bit. A lot of times, by half throttle, I'm going to go ahead and ramp it on in the rest of the way. Especially in, say maybe a boosted application or something where you start to get a little bit of boost pressure kicking in earlier. Something like that would work really well. Alright, next up, a little bit of change to some of the nitrous tables. The progressive power adder. Instead of having two separate tables, one for fuel and one for nitrous, we put those on the same one. So it makes it more convenient, also keeps you from maybe forgetting, if you increase nitrous and forgot to increase fuel. So you can see this here, and basically just hit the tab key to swap back and forth between the two lines. Next up, we changed up the PA ramp retard table a little bit. The PA ramp retard is a time-based timing retard. It helps to keep a car from spinning or wheeling too much. And in the past, we just had 8 columns or 8 points down here across the bottom. Now we've increased that to 16 to give you a bit more control over how quickly that timing ramps back in. And also this one too, when that changed, it also kind of affected this table. If you had it in your old tune, it may look kind of messed up now. So what you need to do is just go ahead and fix that on, based on your time. Because typically, say if you're going to pull 12 degrees on the launch, probably by the time you get on down the track, you're going to want this, your full timing back. So we want to go ahead and just pull that down, and then you could interpolate or set that, curve up however you need to. Basically kind of copy it off of the old tune, but you may have to go in and change these time values down here. So in order to do that, just move your cursor until it turns into the hand with the pointing finger. Double click, and then you can enter, whatever you want to. So if you want, of course, 0 would be at the launch, and then, maybe, 0.2 seconds in, you want to start to change the timing, and just go down through the line, and you can set those up however you want to. Alright, now let's move on to the next one. We're at step number 8. So we want to go up to View, and then down to System Configuration, and then Fuel Calc Parameters. Now this one's pretty similar to the way it used to be. A couple changes here. This one, you want to look at the FP Correction Enable, and you only run this if you're running a fuel pressure sensor that the XFI can read. Basically what it'll do, you have this target here. So with the target fuel pressure is going to be whatever your fuel injectors are rated at. Now this particular injector here, the 36 pounder we're running, is actually rated at 43 psi. So we want to put 43 in the box. And if I had fuel pressure correction enabled, it's if the fuel pressure goes above 43 or below 43, it's actually going to apply a little bit of fuel correction to kind of maintain that same amount of flow. Because as the pressure increases, we're going to get a bit more flow out of the injector. If pressure goes down, the injector doesn't flow as much. So if you're not running a fuel pressure sensor, make sure this is not checked, because it will add a ton of fuel. So hit apply and OK. Next up, we're at step number 9, and we want to do our sensor calibration. Now in the past, when you're running fuel and oil pressure sensors, we would calibrate that through the auxiliary analog sensor setup over here. So like fuel and oil. These don't matter anymore. We actually have dedicated channels now with the 2.051 for fuel pressure and oil pressure. Fuel pressure is auxiliary A, and oil pressure is auxiliary B now. So we want to go down the sensor calibration, and do fuel pressure sensor calibration. And the calibration is real simple. This one's actually already done right. 100 psi is 5 volts on the fast sensors. 0 volts is 0 psi is 1 volt. And then same for the oil pressure. And the calibration is the same. 5 volts equals 100 psi. 1 volt equals 0 psi. You got to make sure you calibrate those there, because the old way, it won't work properly. And that's pretty much it, guys. Like I said, we'll be doing some more videos on flashing XFI and some communication stuff and how to troubleshoot that. If you have any ideas or questions or want us to make a video about something, please let us know. Thanks.